A convolutional neural network, CNN, is a specialized type of artificial neural network that is particularly effective at processing data with a grid-like topology, such as images. They excel at tasks like image recognition, object detection, and image segmentation. Here's a breakdown of how CNNs work. 1. Convolutional layers. The core of a CNN is the convolutional layer. It uses small matrices called filters or kernels to slide over the input image. These filters detect features in the image, such as edges, corners, textures, or shapes. The convolution operation involves multiplying the filter values with the corresponding pixel values in the image and summing them up to create a new feature map. Different filters are used to detect different features, and multiple feature maps are generated. 2. Pooling layers. Pooling layers are used to reduce the spatial dimensions of the feature maps, which helps to decrease the computational load and make the network more robust to small variations in the input. Common pooling operations include max pooling, taking the maximum value in a region, and average pooling, taking the average value. 3. Activation. Functions. Activation functions introduce non-linearity into the network, allowing it to learn complex patterns. Common activation functions include ReLU, rectified linear unit, and sigmoid. 4. Fully connected layers. After the convolutional and pooling layers, the feature maps are flattened into a vector and fed into fully connected layers. These layers perform high-level reasoning and make final predictions, such as classifying the image into different categories. Key features of CNNs: local connectivity. Neurons in a convolutional layer are only connected to a small region of the input, known as the receptive field. This allows the network to learn local patterns in the data. Shared weights. The same filter is used across the entire image, which reduces the number of parameters and makes the network translation invariant, i.e., it can recognize features regardless of their location in the image. Pooling. Pooling layers reduce the dimensionality of the feature maps and provide some level of invariance to small variations in the input. CNNs learn by adjusting the values of the filters and the weights in the fully connected layers. This is done through a process called backpropagation, where the network compares its predictions to the actual labels and adjusts the parameters to minimize the error. Applications of CNNs. Image recognition. Classifying images into different categories, e.g., cats versus dogs. Object detection. Identifying and localizing objects within an image. Image segmentation. Dividing an image into regions that correspond to different objects or parts of objects. Natural language processing. CNNs can also be used for tasks like text classification and sentiment analysis. In summary, CNNs are powerful neural networks that leverage the properties of convolutions to effectively process data with a grid-like topology, making them particularly well-suited for image-related tasks.